So here we go. Today we're going to look at one of our key need-to-knows, which is, of course, sine squared plus cos squared of the same input is equivalent to 1. Okay, or more practically, we often use sine squared x plus cos squared x equals 1, or here we're going to do it with theta. So we're using it to solve this situation that we've got here on the board. We're solving an equation. We're doing it in radians because I can clearly see the pi here. And, well, let's jump into it. So what I want to do here is I need to decide, am I going to solve it in cos or in sine? Sometimes when you do this, you'll sort of see something maybe like this. So you may just see a cos on its own and a sine squared. So the general advice is to substitute out the squared element. Let's do this example first, and I'll show you another one in just a moment. I'm going to make the decision to keep it all in cos. So when I do substitutions, and it's important that I get it right, what I'll often do is I'll assemble what I want from the identity on the side, and I will assemble it so that it's ready for me to use. So I'm going to get sine squared on its own. So sine squared x is going to be equal to 1 minus cos squared x. I'm now going to rewrite this. So again, I've chosen to do this in cos, but there's no reason why you wouldn't do this necessarily in sine. And I'm leaving the bracket there, ready to substitute in my result. So I'm going to substitute in my result now. So 1 minus cos squared x. We multiply everything out. Minus 4, please be careful here. Think of this minus 4 as being the term in front of the bracket. So there'll be a double negative. Watch out for that. So plus 4 cos squared x equals 1. Let's get the cos terms all together. Let's get the trig part on its own. Now, when we're doing this, watch out. There are going to be two solutions. Cos theta as the positive case of root 5 over root 7. Or we could have the negative case. So that would be equal to a minus root 5 over a root 7. Okay, what's left to do here? Well, it's just inverse cos of both sides. Please check that you are in the radians mode on your calculator as you are doing this. So inverse cos of root 5 over root 7 gives me a principal value of 0.5, let's go for, let's do 3 significant figures just to be safe, 0.564. If we think about our cos graph, it is cos, isn't it? Yes. Okay, looking something like this. It seems that I've picked up this value here. So how do I get this one over here? Well, to get your partner value, you need to do 2 pi minus 0.564. And if you do that, you will get 5 point, what did we say? We said we're doing, well, I said significant figures, didn't I? So 5.72. Okay, so those are your first two solutions. When you solve for the negative case, okay, let's have a go with that one there. So inverse cos of root 5 over root 7 gives me my first value. Whoops, I need to put a negative there. So it gives me my first value of 2.5, let's do 2.58. Or if we do 2 pi minus, so remember 2 pi is how you get your other value. So 2 pi minus answer is 3.71. So there you go. We can solve trig equations where we have a mix of cos and sine by using our sine squared plus cos squared. Now, what would have happened if I had changed the question slightly. So we won't answer this full question, but we'll just play around with it a little bit. So I want you to imagine this case instead. So if I had 3 cos theta minus 4 sine squared theta equals 1, the same trick is still useful. Here, this is what I would call like a sticky term, okay? It's awkward to get rid of it because it's not squared. It doesn't work nicely with our identity if we don't want to do some square root thing. So I would keep the sticky term as it is, and I would be looking to substitute out the squared term, okay? So again, this is how we could go about doing it. Okay, so sine squared plus cos squared being equivalent to 1, very, very useful for solving trig equations. Another place where it's quite useful is proving identities. So we're going to prove that this result is equivalent to sec times cosec x. The general advice is to start with one side and work to the other. So we are going to show how the left-hand side can be manipulated into the right-hand side. Reason for this is as follows. There's clearly more to kind of work with on the left-hand side. So that seems the most sensible way to do it. So I'm going to write just tan x plus cot x. A lot of questions where you're adding together separate parts rely on using fractions. So let's do that and let's see how sine squared plus cos squared might come up. So this is equivalent to sine over cos, and cot is the reciprocal. And it's often useful to write them in terms of cos and sine. Well, what might I do next? I might spot that they don't have the same denominator, so I can rectify that by, if I just write a little bit of space, I can rectify that by multiplying to create the same denominators. So this is missing a sine x, so it needs another sine x. This is missing a cos x, so it needs another cos x. And now let's write this in one big fraction. So that is the same as sine squared x plus cos squared x all over sine x cos x. Well, this is the result that we were just talking about here. So this is equivalent to just 1. Okay, so if we write that one out, we're going to have 1 over sine x cos x. And then what we're going to do is we're going to look here for some clues about what to do. So sec is the same as 1 over cos x, isn't it? What's this the same as? This is the same as 1 over sine x, and that dot is being used, okay, to sort of mean the product, or they could just be written next to each other. So looking ahead at this, I think I know what I need to do. I think I'm just going to write this now as 1 over sine x times 1 over cos x. I can test that it takes me back, so that's how I know that I'm correct so far. And finally, I need to write what's actually there. Okay, so this is going to be, I may even shuffle the order actually. So this is then going to be the same as sec x times cosec x as desired. So whether it's solving our equations or whether it's proving results, sine squared plus cos squared, hopefully by now you're appreciating, is really at the start of what we have to do for a lot of A-level maths.